Okay, so this is our part 2 video. Now I'm going to show you how to do the max and min slope possible lines for your graph. The thing that I'm showing you is technically you're really not supposed to do it. However, it works for most of the time, and I feel like if it works, we will do it. So we will just be focusing on the two extreme ends of the data set, here and here. So to make a max slope possible line, I would make a line that just fit within the upper limit of the error bars and the lower limit of the error bars in an attempt to force the data to an extreme maximum value. So to do this, I can take this radius value, and I'm going to actually click equals in here. So I'm going to take the lower x value. And if I wanted to do a max slope possible, I would want to kind of tip this slope forward. Tip it forward and it would exaggerate the slope. If I laid the line down further, the slope would be minimized. So to maximize the slope, I'm going to take this x value, and if I shifted this x value to the right by its uncertainty, so plus 0.01, I would get this value. And then the corresponding y value, I would want it to be lower. This would kind of like tip this lower part down. So I will take the y value, which equals 3.14, and I can subtract the uncertainty from that, 0.01. And in fact, I'll just go ahead and put the uncertainty values, uncertainty in the x, the radius values, the uncertainty and the average z values. They're the same. They're both 0.01, but in real labs, they will very likely be different. Okay, and now I'm going to look at the extreme radius value. This is equal to 1, and to make this more exaggerated, I would want to push it forward here along the x direction. And then if I do that, if I push it forward, I would be subtracting its uncertainty here. And then for the corresponding y value, it's 6.28. So in this, I'm clicking the equal sign. I'll click this entry. And I want to make the graph tall here, so I would then add in the uncertainty value here. So notice I add the uncertainty, the lowest x value. I subtract the uncertainty from the lowest y value. I've subtracted the uncertainty from the highest x value, and then I've added the uncertainty to the highest y value. And that should shift this graph, I'm going to make a new line, and that line should have a greater slope than my best fit, than my line of best fit. So I will now click the graph here, and I'm going to I'm going to right click the graph, and I am going to go to select data. When I go to select data, after right clicking, I will actually edit this because this is my line of best fit, what's been labeled for me average G. I will edit that, and I'll call the series name equal best fit line. Okay. Okay, so no equal sign, I'm sorry, best fit line. And now I'm going to go to add, and this series name will be max slope possible, or max fit. The series x values, I will click equals, and I'm just going to highlight this. My series y values, I keep the equal sign, and then I highlight my y values. And then OK. Hey, it lines up pretty nicely. And then I'm going to add a trend line, more options. I will add the trend line for the max slope possible, okay. I'm going to click got it, this pops up, If this shows and you don't see these values, remember it's the vertical green bars, and I'm going to display equation on chart. Here it is. Hey, my slope is a larger value, and it goes through all of the data points except for my anomalous data point right there. To distinguish this from the best fit possible, I will format this box by clicking this paint can. I'm going to change the color to orange. So now this goes with my max slope possible. Okay, now we're going to do the min slope possible. Just like before, I'm going to think of a way that I could fit a line into these data sets such that I get the minimum values and it would still go through all the error bars. So technically you're not supposed to focus on the extreme data sets, it has worked for almost every lab and it will continue to work, so I have no problem continuing to do it. Again, my X value. Now we want to, I can click into, if you want to do an operation in Excel, if you click a cell entry and you click the equal sign, that sets you up to be able to use the entries to actually do a mathematical operation for you. So let's think. I want to shift this to lay down. I want the min slope possible. So at this minimum X value, I will subtract the uncertainty in the X value. This minus this, okay? And for the corresponding Y value, I would like it to fall, I'm sorry, for the minimum Y value, I'd like to shift it up. I want to lay the line lower so the slope value gets smaller. So I will click equals the corresponding Y value. I want to shift this up, this Y value up. So I will add the uncertainty here. Okay. Equals on this side, I go to the max X value in the data set, and we want to make this lay flat as possible, lay down, kind of rotate down. So I'm going to add the uncertainty here. And then I'll come to my maximum Y value in the data set. Whoops, should have gone equals. I will click this entry. And again, I want to make it lay down, so I'm going to subtract the uncertainty here. And now, right-click my graph, go to select data. We will go to add. The series name is min slope possible or min fit. The series X values, make sure you have the equal sign. Click, drag, hold, it'll populate. Series Y values, click, drag, hold, it'll populate. Okay. All right, we want to add an element here, a trend line, please. More options, and we want the trend line for the min slope possible. Yay. Again, we want to make sure it's visible. Vertical green bars. Display equation on chart. Boom, there it is. You'll see how it's small, like is that like 6 only, so we can format the trend line in a different way with the text, sorry. Not the label options. We want the text options. Okay. If I go here for text options, it gives me a number. Underneath the category, I don't want general. If I can, I'll change it to scientific. And with scientific, I can see, okay, it is 6.00 flat. I will just go back to general then. Okay. All right, so I can see that the slope value is indeed smaller than the best fit, and the max slope possible is indeed larger than the best fit. If I click the box, and I will change the outline color to gray. This way it's really easy for me to distinguish what my line of best fit is, what my max slope possible equation is, and what the min slope possible equation is. And that's how you make a graph in IB. All of these values are linear, but they are not directly proportional because they do not go through the origin. Now I will hit Control C. I don't want a snippet of this. You will actually paste this into the Word document and then Control V. Now, one last thing you do is you want to give some value to your slope. Like, what does it mean? The slope in this case should be, if I look at an equation for y equals mx plus b, in this case, the y value is the circumference, and that's equal to some proportionality constant, whatever this m is, and my x value is the radius. So that m value, my slope value, if I know anything about circumferences and radius, it should be 2 pi as my slope value. Ideally, it would be directly proportional. I wouldn't have this y-intercept, this b value, but I do have a b value because of imprecise measurements or imperfect measurements. So my slope from the line of best fit should be 2 pi. In this case, it's slightly greater than 2 pi. 2 pi is 6.28. Here I have 6.538. All right, so my slope should be 2 pi. It's rather close, at 6.54 centimeters. I'm going to round that up to 6.54. Now, with the max and min slope possible line, you will report error or uncertainty in your slope. So to do the uncertainty in the slope, you take the max slope possible value. In this case, it is 6.58. I'll just round off to there. And you will subtract the min slope possible, which is just plain old 6. And that gives you a value of 0.58 divided by 2. 0.58 divided by 2 is 0.29. So I would report my slope. IB expects you to do this, to analyze what your slope value should be and to the uncertainty in the slope. I would write this value as 6.54 plus or minus 0.29 centimeters. The slope value is 6.54 plus or minus 0.29. Oh, it's actually unitless. I do apologize. That is a unitless number. Goodness, I got the best of myself. And should be equal to 2 pi. Now in the IA, I would then go into in-depth what went wrong, what it showed, and that would be fine. But I have done everything I need to do for my data analysis, the table, everything looks correct, all the digits are concise. I've shown, you will have to show your sample calculations for the average. I've at least showed the sample calculation for the average circumference uncertainty. I have my graph included, everything's labeled, it's easy for people to see. I've done my, I've reported what my slope value is, and I've done the, and I've reported the uncertainty in the slope without units. So I hope you found this video helpful. Thanks for watching and study well.